Don't look at the big thing stadium. What do you want to do, John?
What do you want to start?
It's a
Ready to go? What do you want to start?
Let's talk about the
Just a regular
So on brand. Oh yeah, like concerts.
That's the only thing we do.
Football? I don't know what you mean. What they're playing isn't even football. I don't know what it is. Yeah, they have these weird lines of. Oregon will be playing football. I got a high school team that do better than that.
We're going to throw all the freshmen in high school on play because two high schools sharing the same building.
You won't go to lunch with us today?
He's staying the whole year.
Andrea's coming to lunch with us today.
I saw that he just put out like a
We're ready whenever you want to go.
Okay, can you, is this working? I unmuted, okay. Yeah. Okay, welcome to our weather discussion for this week. We're in a transition, I think, right now. I mean, the weather outside clearly is the case. Last night, before midnight, we got to 31, so Madison already has its first day below freezing, which was yesterday. But then it got down to, this is from Ed Hopkins, got down to 26 by 12Z. So we had our first official day below freezing, the first one since May 9th. That's a long time, 5 months plus. But probably close to the climatological range between the two. I think it's not that far off. So I had 32 at my house. It certainly was the first time we got to freezing. And I think my tomatoes, prolific though they were, are finally probably at the end of their line. Even though they keep on going. New flowers even last this week. They just don't know anything. They just react to the tragedy when it arrives. So here's and I'll just say about the 850 cold pool, we crept up in the standings a little bit this week. We're now the 11th warmest. So we had a relatively chilly week around the hemisphere. The day or two before today, we actually hit the average, and that's only the third time for the whole now 54-day sequence where we've hit the average. We've been below it every other day. So a little bit chillier this week, but I'll give you an update with a graph next week. I like to do that every 2 weeks. Here's our satellite movie over the continental U.S. and adjacent waters, mostly the Atlantic. And if you looked at this, it might be puzzling to figure out what time of year it is without the date on it, because the tropics in the Atlantic and in the Pacific still look marginally active. Of course, Melissa is a little more than marginally active. This is going to be an interesting storm. I'm going to probably let Michael talk about it because it's mostly in the forecast mode. But right now, this is Tropical Storm Melissa. And in the Caribbean, just to the southwest of Dominican Republic and Haiti, and it's going to make its way up towards the Bahamas over the next several days. And there's a little disturbance in the eastern Pacific as well. I don't know if this one has a name or not.
No.
It doesn't? Or it does?
Does not.
It does not. So kind of an interesting looking disturbance there too. Although it does look like somewhat dilapidated tropics. One might not expect it's June, July, or August, but it's certainly, you wouldn't expect it's late October. Some really beautiful diurnal cloud streets across the northern countries of South America and in northern Brazil and in the Amazon basin. So really kind of nice. You can see that so well today. Where it's still muggy and tropical naturally, it no longer is over Florida and the southeast United States. You don't see quite that development like you would have in July or August. So those are some keys about when it might be.
Hey, John.
Yeah.
I don't know if you're going to point this out, and I'm not sure what we're seeing, but in parts of Ontario and Quebec, is that snow cover?
Oh, right in here. I don't know. We'll have to maybe we can take a look at a map for that. I did not check to see. I think earlier this week there had to have been snow flurries in Western Ontario. There had to have been. But I don't think there was probably accumulating snow there. So I don't know what that is. That's a good question. It's been stormy in eastern Canada, though, one after another, and we'll say a little bit about that because I think that trend may well continue. This is a deep upper trough, an expansive upper trough. And on the eastern periphery, there's poleward flow, and you can see some of these cloud streets going up there. This one here at the mouth of the Labrador Sea appears to have that sort of characteristic anticyclonic outflow, so maybe there's a cyclone getting itself organized here north of Newfoundland and at the mouth of the Labrador Sea. But I don't know about this grayness over Ontario. Maybe within a week we'll know just how gray Ontario will feel because they'll either have won the World Series or lost it, and that'll start tonight. Okay, so over the central United States, widespread cloudiness in the lower Mississippi Valley and west of that, so over Kansas, Oklahoma, parts of Texas and Arkansas, and we'll see what that's associated with. You'll be surprised. It's a fairly weak little upper trough, but it's enough to provide a widespread region of cloudiness, and I believe I've seen already that it's precipitating under a large fraction of that, though not all of it. And then lake effect rains and showers across the eastern Great Lakes and probably even the lower part of Michigan, because this is really chilly air. The temperature is like -3 to -5 at 850. That's downright cold for this time of year. Not unusually, not unprecedentedly so, but nonetheless cold. And the lakes probably were a little warmer than average by the time we get to middle October. The summer wasn't so bad. And so downwind of them, some pretty nice lake effect cloudiness, and a few of those clouds are dropping showers. We had that ourselves this week, probably some of it aided by flow over Lake Superior. Later in the winter, before the lake gets frozen, you can actually get snow showers with northerly flow here, and you know they're coming from evaporation off Lake Superior. That's pretty cool, because that's a long way to go. But it sometimes happens. Okay, and then in the western part of the United States along the coast, especially in the northwest, you can see there's some cloudiness over Washington and Oregon that has an extension down to the south and west, and at this oblique angle, one can't really get a great picture of that. We'll look at a better one in a minute. But that's a pretty intense precipitation band, as it turns out. We won't see it on the radar, but we'll be able to interrogate it with a couple of other ways. And strongly frontogenetical, so a really nice example of what happens in the lower troposphere when there's strong frontogenesis and generating precipitation in clouds. Okay, so that's the broad picture over this region of the globe. Can we look at the Pacific satellite first before we go to the radar? We'll do that in just a second. Probably IR is better, yeah. And so you can see a really strong bifurcation between, look at how many open cellular convective cells there are over this vast part of the Northeast Pacific Basin, and then absolutely none south of this ribbon of high clouds, which incidentally, if you watch some of these elements and you've watched them for a long time like I have, they're moving really fast today, and I'll show you why that's the case. We got a 200-knot jet right about here, anticyclonically curved 200-knot jet at 250 millibars. That's rare any time of the year, but it's especially rare in late October. And I'll say this, my sense of looking at this in the evolution, and we can do it together if we want, although I don't intend to, but if people have questions, we certainly will. This does not have an obvious tropical origin. Sometimes something that might happen in the deep eastern Pacific, western Pacific, tropical storm-wise, can pump up the tropopause and drive a strong jetogenesis event that gives you a 200-knot jet. That does not appear to be the case this time. So this one is sort of pristine and native to the extratropics in a way. Really neat. But look at even, you can't help but spawn a few cyclonic disturbances. There's one that's a little more obviously cyclonic in the lower clouds than it is in the upper clouds, right there. There's another one here. And then notice this also. It's not quite as obvious in the colored image as it is in the gray and white one, but nonetheless, not much cloudiness in the sort of west-northwesterly flow. As soon as it rounds the basin, what's an obvious low point in the trophiness here, that's when the clouds get higher and deeper. And so it's a really good example of downstream of an upper trough axis is where the clouds are. Isn't that great? And they get discouraged in the upstream region because there tends to be upper convergence. It's hard for those clouds to form and be sustained, okay? Unless you're well north of the cyclonic shear, and then you benefit from the vorticity. But the number of open cellular pieces here and some of the size of these just off the Washington, British Columbia coast indicate it's pretty chilly at upper levels in this whole region. So we'll see that when we look at the 500 millibar map on the superpeats. And then south of the jet core, it's nowhere near as cold. Of course, the further south you go, you get to Hawaii. ITCZ in this longitude sector looks a little more active than it has over the last couple of weeks, especially to the southeast and then all the way to the southwest of Hawaii. This whole region starts to look like, it's on fire, and it hasn't really looked like that the last couple of weeks, as you might recall. All right, let's look at the radar over the continental U.S. before we go to the superpeats. Pete? Thanks. So here's the precipitation that's detectable by the radars along the west coast, and you can see the whole Puget Sound is raining. I think Seattle had a moment where it wasn't raining. It was heavy rain in Corvallis and some other places along the coast of Oregon, and then moderate rain along the coast of Washington. But pretty solid, continuous influx of these precipitation cells, none of them particularly strongly convective, but some of them a little bit higher in intensity than others. And some of that might be interaction with the orography. I don't know if that's not the case. But a pretty rainy day in the Pacific Northwest. And then here over Oklahoma, Kansas, Missouri, and parts of Arkansas, you can see some intensity varying, sometimes convective and sometimes less than convective, both in Arkansas and in Oklahoma. But widespread, not particularly well organized, but quite a number of precipitation features in this part of the country, and then also in central Texas. It looks a little more convective over the, what is this, the escarpment in West Texas. And then here's some open cellular showery cells over northern Michigan, the same things appearing over Pennsylvania, parts of New York State, in fact, widespread over the central part of New York State, and then even into Vermont, New Hampshire. So that's that cold air, I think, coming over the relatively warm lakes. We're only in late October. You get a really nice lake effect rain in some of these locations, and then showers downstream from that interaction. So that's nicely illustrated in the radar today as well. Why don't we take a look next, Pete, at the, yeah.
I was going to point out a couple things just to note. First of all, the rain that you see in parts of West Texas up through Arkansas and Oklahoma, that's an area to focus on over the next 2 or 3 days because there could be some extreme flooding there.
Okay.
You can also get a sense that the air that's sort of feeding into this ahead of that upper trough that you had mentioned, coming off the Gulf of Mexico, you can see those streaks.
Oh yeah, these things are headed northwest.
That's just really a moist air mass, and we'll probably see when we look at the surface map, the probably high dew point air. I haven't looked at that explicitly, but I'm guessing that's.
Yeah, we should do that.
Dew point air.
That maybe we should do that as the next thing to look at. Yeah, what is the dew point of the air on the Texas Gulf Coast? Because it's clear these cells is a really good point. These cells are coming up to the northwest, so right off the western Gulf of Mexico, pretty warm water there. So can we go to the surface map, the big one map, Pete, and we'll first go down to the Gulf of Mexico and zoom in a couple of other spots as well. So yeah, you hit it right on the head, Michael. Dew points at or just above 70 all along the coast. Right in this like this. I think Victoria has the highest dew point of 71. And then the mid-60s to low 60 dew points go all the way across the state. You don't really dry out even over the higher terrain of West Texas. And thunder showers are certainly the beneficiary of ingesting that lower tropospheric high theta E and a lot of water vapor. So that could be really interesting as time goes on. You're right about that.
And you can see broad sort of warm advection, looking at the change in the varying of wind with height from the elements that we see aloft out of the southeast.
Yeah, that's right.
Yeah.
These were headed this way, and then the surface wind is like that. So yeah, that's a clockwise turning with height. Some of that's frictionally induced, but that's more than is frictionally induced. And also the elements are too high to really benefit from that. So that shearing is deep. That veering is deep, so that's warm air advection. Yeah, all sorts of things going on in the right direction for, unfortunately, high impact weather in a negative sense there. Pacific Northwest, I think you can see some of the, look at that, heavy rain at Portland, or moderate rain at Portland. And earlier it was, stations now not reporting, but earlier there was heavy rain at Corvallis, light rain now in Seattle. So widespread light rain, some heavier rains on the western part of the peninsula, not in Sequim probably, right? Florida knows there's no rain in Sequim, not usually. And so that's the other interesting spot precipitation-wise. And we are, it's no surprise we were cold overnight. Dew points are really low. This is dry air. And but look at how fast it rebounds. 32 at my house, 26 at the airport. The airport's now 16 degrees warmer, 22 degrees warmer than that in just a few hours. That was from 12Z to now, which is probably like an 18Z map. So the sunshine is still quite powerful this time of year. Had it been cloudy after we got to 26, I think we'd be struggling to get out of the 30s perhaps by this hour, maybe just around 40. So it's nice the sun's come out. Okay, can we go to the, ooh, saw a little bit of light snow in Ontario too. Look at that. So that's nice. Snow showers, that's maybe near the lake. But that's not the lake. That's nice. 36 over 32 though, it hits the driveway and melts. So you have to report it to your friends and they have to trust you. Let's go to...
I think another indication, if we go back to that map for a second, Pete, is if you go from Manitoba into Ontario,
yeah.
see there's a temperature increase or decrease
oh,
as
yeah.
you go.
Yeah.
And so I'm wondering if there is that white that we saw on the satellite image might be a light snow cover.
Maybe. I don't know if that's good enough evidence, and I'll tell you why, because we're going to see at the upper level charts, there's a huge ridge in the central part of Canada, and even thicknesses from 1,000 to 500 are anomalously high over that central part of Canada. So I think there's just generally an extraordinarily warm air mass for this time of year. That might be why you see the contrast. You're suggesting perhaps the contrast is there because there's a radiated blanket there,
right.
then that might well be the case. So
We
maybe
could look
both
at
are
a-
happening at the same
We
time.
could look at a satellite image, an RGB satellite image to maybe see.
All
what
right,
it
let's
is.
try and do that.
If I go to all of our GOES Snoops,
I don't think the Snow and Ice Data Center takes, well, it does look at the whole continent, doesn't it? Yeah, it
I'm
does.
thinking of-
So that's another thing we can do.
so usually snow is like a bright green.
Yeah, so there's some green in there, but
But no, those
It
are
looks more like low clouds.
what about a National Snow and Ice Data Center? Can we take a look at that now that we're thinking about this? Because it is a climatologically important variable, and right now especially. Where is the snow cover? And I think they also have an anomaly on there, don't they? How anomalous it is? Like since 1976, just about the satellite era. Yeah, snow today. Just those two words together make me happy. Oh, this is different than it used to be. Yeah, this is just the western U.S. Come on.
Maybe that I'm in the wrong area.
I don't know. This is. Maybe we've become parochial. Boy, wouldn't that be a surprise in the current climate? Northern Hemisphere. Maybe that's ice extent. No. No, I don't know.
Okay, fine, something. I don't know.
Yeah, okay, we'll try it another time, so sorry about that. I thought this, I've been here before in other years, and it's really quick. You see it right away. So, okay, let's go to the super peats then in the interim, and we can always come back. So let's start with our, won't let you select a region, or there's only one region. Let's start with
Go with the super peats.
yeah, 500 millibar map, if we could, Pete. So here's 500 millibars at 7 a.m. this morning. So remember the cloud cover over Kansas, Oklahoma, Arkansas, parts of Texas. I think that's associated with this kind of broad upper trough that's well to the west, kind of over the Four Corners area, and then tilted towards the Baja California. It's not very baroclinic. You can see there's not much temperature contrast here. It's minus 10 near Dallas, and it gets as cold as minus 12 when you get to El Paso, minus 14 up in western Kansas. So this is uniform temperature, but there is some curvature in the flow, and so there's a tendency for upper divergence in this particular region, and that's about where the center of that cloud mass was. We saw some precipitation further south, but some hours after this map was constructed. So this trough has probably made some eastward progress in the interim, and I think that's carrying along with it the forcing for ascent that maybe has the clouds moving east and some of the precipitation elements doing the same thing. But it isn't well organized at 500 millibars, and it's not very cold. It's only minus 18 in southern Colorado. That's not very cold. Over here, with this off the west coast, with this really intense upper level baroclinic zone, these red lines are isotherms every 5 degrees. So when you have 4 of them together, that's a 15-degree temperature contrast. That's squashed into this distance right here, which is maybe, I don't know, 400 kilometers or something. So that's a really strong and lengthy baroclinic zone. Very sharp curvature just off the coast, and we saw in the radar there's some precipitation in the Pacific Northwest in a spot where you might expect there should be at least an encouraging environment for ascent. But this is complicated and made more interesting by the strong thermal contrast. And so we just can't not look at, if the winds are that strong, presumably strong, given the geopotential height gradient at 500 millibars, here in northern Oregon, that distance represents about 60 knots. So this is going to be 60 to maybe 90 to 100 knots. What must it be at upper levels? Let's take a look at the 250 millibar chart. If we could. Well, look at that. 199 knots. Right off on the southwest periphery of the Gulf of Alaska. and it's lengthy. That's an incredibly strong jet core. And, but notice the speed change is meted out over a long distance, so it's really only about right here where you have a really rapid deceleration. That's a good place to have it, because that's also in the spot where you start to get into the cyclonic curvature. So maybe a double whammy for ascent right about here, but not really exactly structured so that you get deep and intense cyclogenesis. It might be just a little bit off kilter there, and we'll see when we go to lower levels that that looks to be the case. And then a little jet streak right off in north of the Washington-Oregon coast. So we're in sort of the left entrance region, or the right entrance region of that one, and that also contributes to a tendency for ascent in the region where we saw the radar echoes. And at upper levels, you can see this feature that we were seeing at 500 is at least got one cut-off contour, but the flow itself does not appear to be cut off. It's just a broad trough. And down sheer of it is where the action is, in the lower troposphere. So that, we're going to interrogate that jet very briefly with Vis 5D in just a minute, because you can't see a 200-knot jet in October and not look at it in a couple of different ways. We have to do that.
John, before you
Yeah.
move on, I was just going to say, I think it's really interesting, in that jet, there's a little like warm strip that's in, I mean, it's GFS.
Right here?
analysis. Yeah, those
Yeah.
are all temperatures warmer than the area.
That's
around
true.
it.
It's
So
43.6 minus 50.
yeah, so, you know, looking at like the geopotential height contours, if you follow one and think of that as like sort of the analogous to a trajectory line,
Yeah.
it's all, like all of that strip is like going through deceleration. So you're getting that really elongated zone of like, you know, DV/DT is upstream.
Yeah, going upwind.
Yeah.
Yeah, that's right, all the way along here.
So, yeah, I
It's-
think just the fact that you see the sinking motion in the temperature contours, I think is interesting.
Yeah, that's a good point. I hadn't seen that, and I looked at a cross section and couldn't really find subsidence. I saw a lot of ascent.
Oh, interesting.
Yeah, a little. I shouldn't say none, but a little bit. It's not really strong, like I thought it might be. But that's a really good point. And
Yeah.
it shows up in the analysis of GFS. That's pretty cool.
I guess when you're at the tropopause, you don't need very strong subsidence to see a big thermal.
That's right, especially right here. I usually look at 300, but I've kind of been looking at 250 a little more regularly, and you're right, the higher you go, man, you got a pancake stack of theta lines,
Yeah,
just
right.
a little tilting, and you get a huge temperature response to that. So that's probably what it is. You'll love this case, because the lower stratosphere looks more interesting than the upper troposphere, in my opinion. So, okay, let's go a little lower. Let's go to 850 and see what that looks like. Oh, wait a minute, 500 again, Pete. I didn't draw our attention to the temperatures in the Gulf of Alaska. Look at this patch at minus 37, roughly in the same spot where you have the warm patch at 250. This is minus 37, so here it's minus 30. That's the whole expansive area of that open cellular convection. So that's a threshold where if you get to minus 30 at 500, surface temperature of the Pacific Ocean here is, you know, don't go swimming, it's probably like 70 degrees C, but you're at 37 degrees over 5.2 kilometers. That's like almost an 8-degree lapse rate. So if you're saturated, you're going up for free. And then everything around you is going down to compensate. So you got all these little towers of free ascent, and that's how you get that population of the open cellular convection. And occasionally, it blobs up. There's a little curvature right there. There's more here, and so you can see those little spots where something might help to organize that ascent a little bit on a broader scale, and that's reflected in what you see in the satellite movie as well.
At
Yeah.
500 as well, just north of North Dakota, you can see also just a really weak shortwave.
Yeah,
Which
right
will
there.
play a
Yep.
role in our weather tomorrow.
Yeah.
Just northern Wisconsin.
That's the only place where it's relatively chilly. Look at these temperatures. Churchill's minus 20 at 500 millimeters on October 24th. That's ridiculously warm. And you can see the minus 20 isotherm goes all the way up to the archipelago, and that's kind of reflective of that real warmth through a deep layer. We'll see it at 850 more dramatically. And the presence of a big ridge over central Canada. So that's why I think at least a competing theory is that it's just unusually warm to the west and maybe a little bit unusually cold in Ontario because it's had the whole week to feel this upper trough, maybe without snow on the ground. But let's go to 850. So at 850, you see a little bit more thermal structure, I think particularly with respect to the feature on the eastern part of North America, this upper trough, which is very expansive. And then on the west coast, here's our minimum in geopotential height. So remember, the jet was way out here. And so the cyclone, if you can even call it that, related to this whole development, I think it's just a broad upper cutoff now, is right here at the Kenai Peninsula, or whatever it is, I forget what it's called, but right here in southern Alaska. And pretty far removed from the jet core. In fact, here's a little disturbance that probably responds to some of the curvature and speed shear in the jet right there. So this cyclone is not particularly in the right position for further intensification. Some of these little disturbances may be, but there is a decent baroclinic zone off the coast of Washington, Oregon, and extending out over the ocean. We'll take a look at that in just a second as well. And that's, I think, a reason why there's an extended region of precipitation out along the coast. And we saw that in the satellite picture, I think, or evidence of it. Here, we've enjoyed 2 or 3 days of a moderate cold advection, or maybe modest cold advection, and now it's about neutral temperature advection, but it got down to -5 in Green Bay, +4 in Minneapolis. There's a big temperature contrast across the river and across our state, and so we're chilly. I don't think Minneapolis got to freezing last night. Maybe they did, but everywhere here did except Milwaukee, too close to the lake. Broad region of -3, -4 air at 850, and that's exactly coincident with all of this lake effect stratocumulus and some of it even showering, as we saw in both the satellite and the radar. But it's about to end, because just to our west, you can see in northern South Dakota, we've got winds turned across the isotherms from warm to cold, and so we're going to start to see either a period, perhaps a prolonged period of no temperature advection, followed by some slight warm advection at 850. And look at how warm it is all the way up into the archipelago. This is -5, the same temperature at Green Bay as you get way up here. Okay? That's quite remarkable. And here's 0, okay? Going off like that. So all of central and then leaning toward western Canada is quite warm. Look at Winnipeg, Lake Winnipeg, strong warm advection at 850. And so all of Manitoba, all of Saskatchewan under pretty decent warm air advection. Not true for Ontario, where it's about neutral, but the whole week's been chilly. Moderate cold or modest cold advection. Okay, let's do one more thing, Pete, before we go to Biz 5D, and that is, can we go to maybe tropical tidbits, if it's handy? And let's look at the west coast and look at the precipitation. Probably has to be bigger than that, sorry. Pacific Basin, maybe this is where we just were. I should have said that. North Pacific will work. Right there. And then if we can go to precip and moisture. Okay, let's go back. Can we go back to 12Z?
That is 12Z today.
But this is a 6-hour ballot at that. So.
We have to go.
Yeah, that's okay, because let's go back to 12Z itself. Okay, that's great, thank you. So you can see, here's a cyclone, 979 millibar low off of the coast of Alaska, but there's not really any clear connection between it and this really well-developed frontal zone that stretches all the way up into British Columbia. But look at how, and here's a little disturbance along the jet in the cold air. But this frontal zone has forecasted precipitation of, modest intensity, so it might be fun to cut a cross-section to that. We'll do that in Biz 5D. And what we'll try to interrogate is, where is there vertical motion to produce the precipitation? How's it related to the frontal structure and the dynamics? But the biggest thing we'll look at in Biz 5D, and this will be the last thing I do, is look at that jet. So let's go to the Biz 5D. I just wanted to point out the feature of interest on the west coast as well. Here's it's a forecast from the GFS from last night, 7 o'clock. This is 0Z on Friday. So here's the 500 millibar, approximate 500 millibar geopotential. These are isobars at 5.4 kilometers, so they look like the 500 millibar geopotential. There's Hawaii, Alaska, Kamchatka, northern Japan, and the west coast of the U.S. So really, look at how strong this flow is across the entire Pacific Basin at the latitude of about San Francisco or Chico, California, something like that. And the cyclone we just saw was right there, and it's well north of this kind of broad upper trough with the strong jet to the south. Let's take that off and put on mean sea level pressure. And there's the cyclone center at sea level, and then theta E. I think it's theta E that I put on here. Yeah, so this shows at 0Z last night where the position of the front that we now see just off the coast at 12Z this morning was about 12 hours ago. And notice it doesn't really make an obvious connection. This is low-level theta E, only about 0.9 kilometers, 900 meters above the ground. It doesn't make an obvious connection back to this low. This thing is just a stagnant, amalgamated region of low pressure over the southern coast of Alaska, well north of the jet. But this front is pretty interesting, and it does fit into a nice pressure trough there, you can see. So let's put a cross-section of theta. I think it's on the bottom now. I'm going to slide all the way to the bottom because I have two different cross-sections of theta. So theta prime. Yeah, let's do that. And this is how we're going to cut it right through the front, and it's a long cross-section, of course. So let's tip that up, and you can see that right about where it hits that theta E gradient above the ground, that's a pretty nice theta gradient throughout the troposphere. This is probably about 6 or 7 kilometers high, or 8 kilometers high. And then let's put frontogenesis on there. That's that one there. And we can take these horizontal ones off because they're kind of in the way. Thanks. And so there's the horizontal frontogenesis function. Beautiful relationship with the strong gradient of theta. Comes right down to the ground. And then we can put vertical motion, W prime, I guess is a different one. And there's our plume of vertical motion. It seems to have an obvious relationship to that axis of frontogenesis. There may be something else going on here as well that's not particularly accounted for by that. But anyway, it's a pretty nice relationship, and that helps to give you an idea why it might be precipitating along that boundary, even though that front is not so strongly connected to the cyclone well to its northwest. The front itself has its own dynamics operating here, and those dynamics are sufficient to produce some of that precipitation. It would be well worth investigating, is there some other agent of driving this upper tropospheric vertical motion? I won't do that because we don't have the time. So that's one feature in the west. Let's go back to the top view, Pete. And we'll get rid of these cross sections. We won't see them again. And let's put speed on top here. So right there. And this is at 8.6 kilometers. These are every 10 meters per second, starting at 30. So 30, 40, 50, 60, 70, 80, 90 meters per second. This is an intense jet. Okay, this is the analysis from 0Z. I think I put a cross-section through it at this time, not quite the 12Z time. So let's see if that's right. Did I do that? Yeah. So this is theta, we're going to look at in a minute, that cuts right through the core of the jet. We're also going to look at the PV that goes right through the core of the jet. And then later we'll look at omega. So let's take the PV off and then flip this up so we can see what the...
From the east or the west?
From the east. Thanks. Look at that. Pete knows exactly what the question asked. So these are dry isotopes every 3 degrees Kelvin. So there's an intense upper baroclinic zone. And I'll challenge you, is there a strong front at the ground? Doesn't look like it. This thing's all contained in the upper troposphere. Gets pretty close to the ground, maybe about here, but it's not really intercepting the ground. And then there's an extraordinary lower stratospheric front in this case. Look at how strong that theta gradient is along that angle. Let's put the PV on there, Pete. This is every 1 PV unit without no zeros. And it's a wall. So the 1 PVU isotel goes from this level, which we'll investigate the height in a minute, straight up like a wall to that one. And the strong PV gradient on theta surfaces is where the jet core is. And that's where you'd put it anyway. If you didn't even know, you'd probably say it's right about here. In fact, why don't we take a look at that? I think I put that on there. No, I didn't. We have to arrange it. Sorry. And we'll do every 10 meters per second, starting at 30. And go to like 150 or something to make sure we cover all the bases. And then do the same view. And that's an intense jet. So look at all the things that come out of this. Thanks for the zoom in, 2P. Every 10 meters per second, starting at 30. If we take the PV off for the time being, it's a little bit less cluttered, and you'll be able to see the following relationship. Where the horizontal temperature gradient in green is strong, the vertical shear is strong. That has to be the case. That's the thermal wind. Same is true in the lower stratosphere. Strong horizontal temperature gradient, strong vertical shear. Not true at the jet core. Very little horizontal temperature gradient right at the jet core, right? And then anticyclonic shear has very weak thermal contrast with it. The strong cyclonic shear is up in the... Look at this difference between the level of the tropopause on this side and over here. It's unbelievable. And then if we put PV back on, then you can see that that region of really strong horizontal PV gradient in purple on these isotopes is exactly where the jet core is. And that also has to be true. That can be shown theoretically and analytically. So it's a beautiful example of that. But these winds at 30 meters per second escape the box in Vis 5D, which is 17.9 kilometers high. So this is a really exceptional jet. And the level of maximum wind speed is well above where it often is. It's something like 9.5 or 10 kilometers. So it's a little bit higher than you expect. And it's right in the 335 to 340 Kelvin range. So I think it's a superposed feature as well, although maybe that's wrong. I shouldn't say that. But what a contrast between stratosphere in the extratropics and, stratosphere at high latitudes and still in the troposphere on the anticyclonic shear side of the jet with a PV wall separating the two. And that PV wall is exactly coincident with the strong vortex and jet core presented by the jet. So it's a really intense jet. I think that's all I'm going to say. I put W on here too, I think, but I forget what it shows. This is subsidence, right? Yeah, these are all subsident regions, so negative vertical motion, and there's subsidence right through the jet core. And if we put the PV back on, that helps to drag some of this PV down isentropes, accounts for how it's gotten this far down in the lower troposphere, which is probably about 650 or 700 millibars. So sometimes it's stronger than that, but it's almost always going to be subsident right through the jet core to produce these kinds of folds in the tropopause. And this is a good example of that.
So John, is this, you just mentioned in passing, I think it might be a superposed jet, but could it be a pure subtropical jet?
I actually should have taken that back. I think this thing had its origin in the extratropics almost entirely. So I think this is just a really strong first of the season example of a polar jet. But that's worthy of investigation. I don't know the answer off the top of my head. I have a suspicion that it's not got much of a tropical connection.
I was gonna say, it has too much of a upper tropospheric front for it to be a subtropical jet in my head.
Oh, yeah, I
You
didn't
don't really see that
think of that.
tropospheric baroclinicity for the subtropical jet.
Yeah, that's true. That's true. And I wonder if there's such a distinction to be made about what goes on in the lower stratosphere. Never thought about that.
So is the
You know.
lack of a true front, I mean, there's a temperature gradient at the surface, but the lack of a true front at the surface more just due to the fact that it's over an ocean?
I don't think so, because even just above that boundary layer, there's very little, there's not zero gradient, and there'd be a local maximum, I guess. But it's spread out over a much wider zone in the lower troposphere than it is in the upper troposphere. So it makes me think this is just an inevitable consequence of the isotropes having to finally take a horizontal orientation, and somewhere before they do, there's going to be a gradient. But it's really not frontal. If we put the vorticity on there, you'd see there's not much vortex structure along this portion of that gradient, but there is along all of this. It's really strong. In fact, that's why there's the PV there.
Okay. And just one other question. The cross-section through the rain band off the west coast, when you
Yeah.
said that, you were suggesting that that front wasn't, I'm not sure you suggested this, but it's the front associated with the cyclone over Alaska.
I think so, yes.
Okay,
But
okay.
it's kind of a vestigial connection, is what I would say.
So if we went back a day or 2 days, we would have probably seen the nice.
That's
Okay.
probably right. Yeah, you probably would see a better, more obvious connection between that cyclone center and that frontal zone. And it's just kind of shed that as it's kind of begun to cut off and rotate around in the northern Gulf of Alaska. That's my guess.
John,
Yeah.
with, this is kind of tangential, but the second jet core to the east,
Over the Pacific Northwest,
Yeah.
or near the Pacific
Yeah.
Northwest, yeah.
would that have began as part of the same jet core or a separate development?
I don't know. The only way to interrogate that is to actually look at it. The advantage that one has is there's a little bit of diabatic heating to its immediate east, and so that can help to steepen the tropopause there and maybe intensify the jet. And it's downstream of a pretty sharp trough, so I don't remember if that thing was, that trough developed as a feature at the end of the western jet or not. That would be the way I would begin to think about it. Okay, that's all I have. Any other comments or questions? Pete, thanks again for expert driving as always.
So I guess, as you were making the transition, there's a big warm blob in the Pacific, North Pacific right now, ocean warm blob, SST.
Oh, yeah.
And, we were looking at thicknesses over Siberia in like 904. And we've been talking about this extended jet across the Pacific for the last couple of weeks. Do you think anything is, like, as the cold season is sort of cooling Siberia, and we have this big warm blob across the North Pacific. Do you think that?
Never thought of that.
Okay.
That makes sense to me. I guess I'll admit a bias here that I'll probably get in trouble for. I find it difficult to imagine that thicknesses are influenced by sea surface temperatures to such an extent at middle and high latitudes that that's a predominant factor. But I wonder if it doesn't modify the passage of disturbances in the whole lower troposphere in such a regular manner that it adds up in that way.
Across a couple.
Yeah.
Yeah.
So I don't know.
Right, but also gives the potential for more water vapor to get evaporated from the surface, just that warmer water,
Yeah.
probably more water vapor available to, once it's transported into the middle and upper troposphere, warm that to create a stronger thickness gradient.
Yeah, I think there may be some very
The late
strong
heat release.
indirect, I guess you call them indirect, they're not the primary response to the SST, but they have to feed back like that. So that's a really good question. I wonder if that's gonna modify the whole basin circulation for some period of time until it calms down. This is a really extended jet, that's unusual at any time of year. It's on the periphery of the SAS.
And that probably will, and probably have an influence on this upcoming winter in terms of the overall circulation for us. Okay. All right, so we're going to go from mid-latitudes down back to the tropics, and we'll first go to NHC. Have a disturbance in the Atlantic that's now at 60-mile-per-hour winds. Melissa's just been upgraded. There was an update that was just given probably about half an hour, 45 minutes ago from the Hurricane Center. Where is it now? So 60, there you go, 60-mile-per-hour winds. And this is really going to be it'll be interesting to look at the track of this disturbance. If we click on it for just a second, we'll get some of the key messages for the upcoming event. I think the really big threat is the fact that it's going to be such a slow-moving storm, and one that has the potential to intensify significantly over the next 60 hours or so as it passes south of Haiti and Jamaica. Because it's slow-moving, prolific rainfall, and these are one of the interesting things. I hadn't noticed this before on NHC products, but they have this hatched area which indicates some uncertainty in the high uncertainty in the precipitation amounts on this particular product. But you're looking at places locally getting isolated amounts of over 10 inches of rain, and offshore of southwestern Haiti and just to the east of Jamaica, they're looking at rainfall amounts of 20 to 30 inches over the Caribbean. This is significant. And you have a depth of the sort of thermocline in this region, I think it's 60 meters deep, warm water up to 30 degrees Celsius. So this has the potential for significant intensification. Slow moving, so even if the winds don't ramp up significantly, what they're forecast to do, you can see it becomes a major hurricane as it passes south of Kingston later this weekend and early next week. There's going to be heavy rain there, flooding, probably catastrophic rainfall over parts of Haiti and Jamaica if the track verifies. And also with the structure of the coast there, probably significant storm surge flooding into near the airport in Kingston, Manly Airport there. It's not going to be a good situation in the Central Caribbean and Western Caribbean as we get into early next week. So that's what we're going to be watching for. We'll look at the track of this in a bit, but you can see again some of the key messages that the Hurricane Center has. The damaging winds in Cuba later on, but also the opportunity for significant landslides and storm surge flooding in Jamaica, as well as over Haiti getting significant wind.
Is this a new threat for this season, the post-tropical cyclone season? Historically,
Right.
post-tropical cyclone season. Is there an emerging new threat for parts of the Caribbean that you get these tropical storms, they come late, and they don't develop into hurricanes, so you don't have quite the hurricane threat, but they move slowly, and they have extraordinary flood potential. Is that an emerging
I think
threat?
the emerging threat more is the flooding from these storms, again, because I think they're in an environment that is just so warm, the sea surface temperature is so warm.
Yeah.
There's a lot of potential for evaporation of significant water off the ocean surface. Creating this flooding, I think, is important. But the slow motion of this, I think, this is just an unusual period in this part of the world for the steering currents are just weak. But I don't think this is necessarily a new threat over the last few decades or so beginning to emerge. But this is actually expected to intensify. It's just been struggling, and we'll see when we go to a SIMS product in just a moment that there's been some shear over it that's disrupting the circulation. But just over the last couple of hours, they've had a hurricane reconnaissance in there. The advisory at 11 a.m. was initially 45 mile per hour winds. Now they've just upped it to 60. So maybe the organization is beginning to take over on this particular storm. If we scroll back up to the official track, we'll go to the cone, which is more like a squashed cone or whatever that someone stepped on it. Look, it's just not very slow motion. So this is where the cyclone may be. I think it's at 120 hours or so, anywhere in this range right here. But in the short term, here's the forecast going from tropical storm to hurricane, and then sometime during the Sunday afternoon becoming a major hurricane. And there's a possibility of a rapid intensification period later on this weekend as it just travels south of Jamaica. Obviously, if the track is further or closer to Jamaica, they're going to get, that could weaken the storm a bit more. But it's expected to maintain be a major hurricane as it crosses between Jamaica and eastern Cuba middle of next week. So this will be something that will be in the news probably through middle of next week, if not longer. And then what happens once it emerges off of Cuba and moves into the Atlantic remains to be seen. But I think all the forecast or most of the forecast guidance right now has that heading out to sea. So let's go to the SIMS page. We have that up and click on Melissa. And there was something I tried to bring up a while back earlier this season. So they have an interesting MPI. This is the maximum potential intensity for a tropical cyclone, both in terms of sea level pressure and wind. And this is determined based on some assumptions made about the structure of the troposphere, the information about the relative humidity, sea surface temperature, tropopause level temperature, and the structure of the wind and pressure fields. You can come up with a pretty good estimate for what the maximum intensity of this tropical cyclone could be, with some also assumptions about the efficiency of the Carnot-like cycle. And so when we click on this, we'll first look at sea level pressure. We can see these contours in here that's 875, not 975. It could potentially get as deep as 875 hectopascal, and there's actually 850 there just south of Cuba. That's extreme. That's not a forecast. That's just the potential for intensity if certain conditions were to hold. But you can see again the potential for a really intense cyclone south of Jamaica is there, based on sea surface temperatures, outflow level temperatures for the convection associated with that. In terms of wind, again, you make some assumptions about the structure of the vortex. You get the potential for winds in these regions. This looks weird. This doesn't look right. Yeah, that doesn't, something's not right, unless it's gone off the charts on there. I don't think that's the case. That's not the case. This map, there's something odd about it. But in any case, you can see the track of the storm through here. Let's get away from this for a moment, and I want to go to, I had a list of things, I don't know if you brought all of them up just yet. Here is from Tomer Berg's webpage. Again, this is the official track, the latest official track for the tropical cyclone. You can see it's a historic track, but let's look at some of the forecast outputs from some of the ensembles or super ensembles. Let's look at the super ensemble. Actually, let's do the ensembles first. Just do this quickly. So this is for the GFS ensemble, global ensemble, with lines, no lines, or just the ensemble, each of the ensemble members. What he's showing here in the shading is the probability of the center location passing, based on the ensemble forecast, within 150 kilometers of a particular point. And you can see, again, most of these tracks take the storm across western Cuba and then out to sea. And this is based on the 6Z forecast cycle. I don't know if the 12Z is in yet. So click on this, please, Pete, to see the updated. Check on that. Nope, go to the bottom, not in yet. Let's go to another quick look at some other forecast cycles. EPS, this is the ensemble prediction system from East UW-AOS. And you can see it's a little bit shorter in the forecast, but this is the spread for this. But you can see again, the idea is it's going to be staying pretty close to western Cuba. And one more ensemble member. Let's see what else they have. They actually have, interestingly, a couple of the AI ensembles. And one of the things I want to point out is this GenCast, this is the Google, one of the Google Ensemble members, has actually performed better than any of the operational models this season. This is one of the, I want to make sure it's GenCast, there's a lot different versions of Google's AI model, but you can see this looks pretty similar to what we see for the GFS, what we'll see for the ECWF as well. This track, again, just across western Jamaica and then across eastern Cuba and then into the Atlantic. A few members that might recurve back toward the northeast or southeast Canada, so we have to watch that over time. Let's see, Pete, there was, I'm trying to see, I had not, if we can skip this for just a second and go, was this, there was another link I had there. This is from Blue Sky. Yeah, that one. This is something I want to show you that's kind of an interesting thing. So Brian Nolde, who's at University of Miami, has been looking at Google's DeepMind model for this particular hurricane season. We can click on each of these. This is the track verification. So far, these are preliminary results. This is mean error for the forecast track for a bunch of different models. These are the HAVS models. These are relatively new hurricane forecast models, hurricane analysis and forecast system by NOAA. They have an A and B. There are differences in physics and boundary layer schemes for these models. You have the aviation model, the GFS model, but here's the Google DeepMind's forecast in this purple color. And you can see, and then also there's the official forecast track, and then this is the average of the official forecast tracks, the accuracy typically over the previous 4 years. What we can see, what stands out conspicuously here is this AI-generated forecast track for the tropical cyclones through, I guess, just this past week for all of this season has been considerably lower in terms of track errors, which is really an interesting aspect of that. It's beating out some of the operational models. It's even beating out the sort of human final determined forecast, official forecast track, which I think is really a neat outcome, an interesting outcome in this early days of using some of these products. But NOAA's begun looking at this output, and it's becoming part of their forecast product process, and they're also including it in their discussions. If you go back a click, or click on that, or go to the next image, this is for intensity. And beyond 24 hours, this is actually doing pretty well, again, compared to some of the other guidance that's available to forecasters, which I think is an interesting aspect. The why of this, why is this doing much better, is still an unknown thing. I can't explain this. And again, these are preliminary results that this individual, this professor, has posted for an analysis of these forecast products. There are other folks have chimed in on this discussion, saying that they've looked at, NOAA has been doing this actually for the last 3 or 4 years, or they've done some back retro forecasting, and have found that these AI forecasts, particularly the Google one, has done better than most of the other guidance. So this is something that's an emerging tool for forecasters that could certainly help save lives and property. Yes.
I think I read the forecast discussion this morning, and they said that every single member of the Google DeepMind ensemble has this getting a category 4 or stronger.
Yeah, so given the fact that the absolute errors and intensities here are lower, and you're seeing that in that model, that might have influenced some of their forecast that's going on there. But we also see that the environment that it's in is also one favorable for intensification. If we could go back briefly to the SIMS page for a second, Pete. I think it was that.
Is there any chance that Google doesn't disclose all of their output because it's proprietary?
I think they're sharing their model, the weights for the AI models. I think they're doing this in collaboration with the Hurricane Center.
Oh,
so they wouldn't,
okay.
I don't think the Hurricane Center would be using this if there was a sort of lockdown on some of this. I think this is broadly they may have another model that they've developed that they're still working on, but at least the one that's operationally, Google's, I think, sharing this in a cooperative fashion. Just to get a look at the hurricane itself, since we can get some, so we can look at the visible imagery, 1 kilometer, and we'll loop it. And you can see, again, this deep convection beginning to develop around the center. And the other interesting thing was the cyclone center actually drifted to the southeast earlier this morning from the 5 a.m. to 11 a.m. update. So that's been another kind of oddity with this. But this is really going to town. And maybe the IR might be a better one to look at, IR NHC, to see the convection. So a little bit clearer to see here with the really cooling cloud tops really close to the cyclone center this morning, or to the early afternoon. So this has potential to become a really dangerous storm. But I think the flooding aspects are the thing that's most critical for Jamaica. Okay, so let's go to, just briefly, time is short, our forecast. A couple things that are interesting for us. We can go to Kai, somewhere up there. And we'll go to the meteorogram. The bottom just shows the, I just have to show it because John loves meteorograms, at least the name he does. Again, warming up over the weekend, but still relatively cool, temperatures in the 50s. I think just add about 2 or 3 degrees Celsius to each of these actual forecast outputs to get that dew point still broken, and a dry weekend. The time height section shows something really interesting, and it kind of reminds me of what you were showing, John, with the jet, the cross sections through the jet that you showed. So this is really a neat feature. First of all, we have the dynamical tropopause getting down to, 450 hectopascal. That's a rarity this semester. This is that little upper trough that we saw in the superpeats that was just north of North Dakota. This is in a northwesterly flow. It actually passes by us over the weekend, tomorrow afternoon, tomorrow evening. As it passes by, we get, as it begins to approach, we begin to get some upward vertical motion. Ascent occurs. The column above us begins to approach saturation, so there's the possibility of some clouds beginning to form. And then things dry out, but it's nothing so moist that we actually get precipitation at the surface. And then broad subsidence comes in behind it. But what I think is really curious is this layer from about 700 hectopascal below that just seems unaffected and uninterested in what's going on aloft. Look at these winds. Up aloft, we have westerly winds ahead of the trough. Winds become northwesterly as it's begins to approach, and then eventually the winds, at 400 millibars, begin to turn easterly, which is also kind of an interesting thing. Meanwhile, at the surface, kind of light and variable winds that we have this afternoon, maybe a strengthening, freshening wind out of the south-southeast, and it just persists. So a lot of things happening above us that seem disconnected from what's happening closer to the surface.
Yeah, we've just had this is really interesting. We just had this period of pretty chilly air. So the stability in the boundary layer is about as strong as we've seen all year long. And then this thing floats by over it, and it can't move the air up or down.
Right. I mean, I wouldn't, bet with a basketball that you could drop, bounce it on top of this layer. I don't know why I thought about betting a basketball, but maybe that's something to do. But you could, this is a pretty stable layer, right? Nothing's going to it's penetrating through it. So that's really kind of an interesting aspect right there.
And imagine if there was a foot of fresh snow that had come with this cold snap in January. You could have this thing going right over across, and no way you'd move that air in the boundary.
Right, it would be just stuck in whatever, and then over time when that the snow begins to sublimate, get clouds in there and it's trapped in there for the rest of the winter.
Wow,
so
that's really interesting.
That's kind of just a neat aspect there. Let's quickly go to look at the surface maps. Again, pretty quiet over the U.S.
Real quick, I just noticed there was a comment online when you were talking about the tropical cyclone. Melissa Breeden, one of our alumni, says, "This is not the storm I want it to become."
Melbourne, okay. Let's go up to the surface map, and we can go to the loop and then just stop it. We'll let it loop once. A couple things to see here. First of all, as this trough feature that's was just north of North Dakota, Saskatchewan and Manitoba heads southeast, you can see the little thickness trough, and then it kind of just fades as it heads southeastward. But it does pass by us, and it actually does produce a little bit of precip in the northern part of our state. I'm losing track of the time here on how far we're on in this loop. I should probably make these maps just a little bit smaller. We're at 60 hours. If we can go back to the beginning for a second, Pete. Yeah, these maps are way too big. Let's just watch again in the southern plains. Again, this rain event, which I think could be a significant threat, and we'll look at the total accumulated amounts as that upper trough moves toward the east. Again, we have that really moist southeast flow from off the Gulf of Mexico. Really heavy rains with this very slow-moving system in the southeast, and we just keep. It's persistent. And so if we look at the rainfall totals, let's get out of this. Again, nothing much happening over us over this weekend, but if we look at the rainfall totals in the forecast, we see rainfall in excess of 4 inches across the southern plains. So this is going to be a really wet period for them. So that might be another news story. Because this is on the boundary of our domain for the model run, You're not seeing much from Hurricane Melissa and of the tropics, so that's going to be pretty quiet. And the last vestiges of that, I know you don't like the term atmospheric river, but that's impacting the west coast of the United States. You can see the rainfall, significant rainfall in the Cascades and mountains over there.
Yeah, you can see both of the mountain ranges.
Yeah.
You can't miss them.
Right, and then again, that's that light precip for the total precip. So for us, for this weekend, it looks really relatively quiet. Let's just quickly go to Pivotal and finish this off in 1 minute, I guess. Something about this room, and when I speak in it, I go over time. And students in 610 will attest. I want to bring this up. This is kind of neat. Snow depth, we can see, so what I was seeing on those maps we saw earlier, I'm still puzzled why it didn't seem to be moving at all when during the animation. But the only places of really snowfall, or snow on the ground, were in central Ontario and central Quebec. So that wasn't snow. And if we go to the surface map, we can do just one quick loop through this.
None yet in the prairies either. That's getting
quiet.
to be a little late.
But bring it on, it'll happen. If not this winter, next winter. So.
Yeah, right.
So there's that rainfall event in the southern plains. And this weather system slowly tracks eastward. It is interesting to note, and maybe we can just quickly look at the Eastern WF run as well. But there is, some of the runs earlier this week were putting a fairly intense cyclone right off the southeast, or off the mid-Atlantic coast and the east coast of North Carolina by midweek next week. And that doesn't really seem to happen in this forecast. And for us, it looks like as we go into week 2, just cold with little clipper-type systems passing through. So,
that's snow in New England.
Yep, before we really get much here. So there you go. And there's that trough passing by. If you just go to Eastern WF and then we'll end it. It's not all the way out, but that's fine. And we'll loop it. I think we'll see a slightly different progression of this weather system as it heads toward the Carolina coast. Again, a bit more intense, but now it's actually much more progressive in its motion as it goes east. And there's Melissa passing by, I think creeping more and more into this window of what's being displayed for the forecast output. So I think for the Canadian Maritimes and maybe northern New England, that's something to watch over the next week. This time next week, we might be talking about something happening up in here. So there we are. But there's that track just offshore, maybe crossing over Bermuda, but maybe it might hook back. Anyway, have a good weekend. Again, tomorrow, maybe some clouds in the afternoon, but not much change in wind. Winds will be out of the south, southeast, and then just a dry weekend, and then warming up a little bit more on Sunday. And that's it. It's relatively dry. Thanks, Pete. Thanks, John. Thanks for the questions and comments.
Yeah, it's getting exciting.